Hello guys, this is Kamuti Given from Kamuti Academy. In today's lesson, we're going to look at ionic bonding. So this is a subtopic under bonding, right? So now we have a question that we're going to look at there before we can actually solve. So question reads, explain diagrammatically how an ionic bond forms between sodium and chlorine atoms. Consider the following. So they've given us these, they are called electronic configurations. They've given us the electronic configuration of sodium as well as the configuration of chlorine. So now, if you don't know how to go about electronic configurations, I can do a separate video to just explain electronic configurations. Therefore, let us solve this question. So the solutions. The first thing we're going to do is that we're going to draw the structures of sodium and chlorine before we can go about finding the final results. So now, the structure of sodium, the 2,8, 1, they represent electrons. So together, they are called an atomic number. The atomic number is equal to the number of electrons. So this simply tells us to say these are shells. In shell number 1, there are 2 electrons, 8 electrons in shell number 2, 1 electron in shell number 3. Same as chlorine there. So now, the kind of bonding that we're going to do here is what we call a dot and cross diagram. Right? Follow me. So the first thing that I'll do to write for sodium is that I'll write, have you seen the sodium atom to represent the nucleus? So then in the first shell, like that, in the first shell, there are 2 electrons. So I'm going to represent this by crosses. So I'll represent 2 crosses like that. 1, 2. So 2 electrons in the first shell. In the second shell, shell number 2, there are going to be how many electrons? 8 electrons. So we're going to represent the 8 electrons like that using crosses. 8 electrons. Then in the last shell, there is only 1 electron. Last shell, there is only 1 electron. So that is our sodium there. Then we go to chlorine. So I'll write chlorine there. So I'll represent the nucleus. Then I'll start. In the first shell, there are 2 electrons using dots to just differentiate the 2. Then in the second shell, there are 8 electrons, like that. 8 electrons. Then in the final shell, there are 7 electrons. All right. All right. Now, this kind of bonding, ionic bonding, this is the type of bonding whereby a metallic atom loses or donates an electron to a non-metallic atom. Now, we have sodium and chlorine. Which one do you think is a metal? Of course, a metal is sodium. There are different methods. There is a way in which you can find out if you don't know to say this element is a metal and they give you the electronic configuration, you can know, you can tell. So usually, metals, they've got between 1 to 3 electrons in their outermost shell. So now, we've got 1 electron in its outermost shell. So sodium is a metal. Then chlorine, it has 4 and above electrons. So chlorine is a non-metal. So sodium is going to donate an electron to chlorine. Now look at, in order for chlorine to be stable, now the major reason why bonding occurs is that these atoms, they want to attain a stability such as that of the noble gases. You know, the noble gases on the periodic table, they're very much stable. No wonder they are called the noble gases, the inert gases. So now, in this one now, chlorine can only be stable if it has an octet number of electrons in its outermost shell. By octet, we simply mean 8 electrons. So here it has 7. In order for it to be stable, it should have 8 electrons. So now, then this sodium does not need any electron because a metal does not gain, it donates. So this sodium should lose this 1 electron so that it can be gained by the chlorine. So look at what will happen. So there will be a transfer of electrons. So this one, an electron here will move. So this 1 electron will go there. So what will be formed? Now, follow me. So we have sodium here. In the first shell, the 2 electrons remain. Then in the second shell, we have 8 electrons. Now, this second shell is becoming the last shell. So this second shell has actually become the last shell. Now, why? Now, I want you to observe something. When a metal loses an electron, it attains a positive charge. So this sodium has lost 1 electron, so I'm going to put a positive charge to signify that sodium has lost 1 electron. So hence a positive charge there. What of chlorine there? So chlorine, we have our chlorine there, Cl. In the first shell, we're going to have 2 electrons. In the second shell, we maintain the 8 electrons that are there because bonding occurs between the outermost electrons. Then in the last shell, since it has gained an electron, it will have 8. So now look at what will happen. So like that. Then we have that, and we have a cross here. We have maintained the cross to signify that there is an electron that is coming from the sodium. Now we've maintained it there. So I'm going to do that. So since it has gained 1 electron, when a metal gains an electron, we're going to represent that one with a negative charge. So this is how an ionic bond between sodium, so this is sodium, between sodium and chlorine. So this is all together, these they make sodium chloride, our table salt, the one that we mostly use. So this is how ionic bonding can occur. So in the next lesson, I'll teach you about other types of bonding, like covalent bonding, metallic bonding. So if you still have any other questions on ionic bonding, questions on the electronic configurations, questions on how to draw these structures, feel free to drop them in the comment section. Thank you so much, and see you in the next lesson.